a superheated cloud of rock and gas is moving down the slopes of Mayon Volcano in the Philippines. Not smoke, not an ash plume, but a solid, ground-hugging avalanche of volcanic debris. It travels over 100 kilometers per hour at temperatures hot enough to turn soil to glass. As of this week, the Philippine Institute of Volcanology and Seismology has raised the alert level, forcing an expansion of the mandatory evacuation zone. Over 50,000 people living inside the permanent danger zone are now facing the direct and immediate threat of one of the planet's most lethal volcanic phenomena. An official photograph from the Albay Public Safety and Emergency Management Office shows the scene. A vast, churning gray mass, a pyroclastic density current, is descending the southeastern slope, funneling into the deep scar of the Bonga Gully. It is daytime, but the cloud is so dense it creates its own shadow, a moving zone of twilight that consumes everything it touches. But here's the detail that tells the real story. In the foreground of that photograph, a farmer's field lies fallow, recently plowed. It sits just outside the established 6-kilometer danger radius, a line that for decades represented a fragile covenant between the volcano and the people who farm its fertile slopes. That line has now been breached. The new threat is a reminder that the volcano's danger is not a fixed boundary on a map. It is a living, breathing variable. And the strangest part of this story is not that Mayon is erupting. It is the specific character of this eruption and what its terrifying speed reveals about the pressure building deep beneath the surface. To understand what is happening in the Bicol region of Luzon, you have to understand the event of February 9, 1993. On that Tuesday morning, Mayon Volcano stood quiet. There had been no significant warning, no major seismic swarm, no official declaration of an imminent eruption from PHIVOLCS. Several dozen farmers were working on their small plots of land high on the volcano's southeastern flank, inside what they knew was the danger zone, but a zone that had been peaceful for years. At approximately 12:57 p.m., without prelude, a portion of the summit lava dome collapsed. It released a pyroclastic flow, the phenomenon known locally as an Uson. The cloud was not large by Mayon's historical standards, but it was incredibly fast and intensely hot. It descended the Bonga Gully, the same channel being used by the current flows, and in less than 3 minutes it reached the lower slopes. The farmers had no time to run. They were caught in the open, tending their crops, under the serene gaze of the perfect cone. The descending wall of heat and ash was absolute. 77 people lost their lives that afternoon. Most were farmers, but among the dead were also volcanologists who had been conducting field research, a stark testament to the volcano's terrifying unpredictability. A survivor later recounted seeing the cloud appear at the summit, and moments later feeling the searing heat. The time between sight and impact was too short for conscious thought, let alone escape. The 1993 tragedy fundamentally changed how the population and the authorities prepared for Mayon's wrath. It was a lesson written in ash that the volcano's beauty is a mask for an unforgiving and immediate lethality. The quiet periods are not periods of safety. They are periods of building pressure. Zoom out, and the geography makes the mechanism clear. Mayon Volcano is a stratovolcano, a 2,462-meter tall composite cone built from millennia of layered lava flows, ash, and rock. It sits directly on the Pacific Ring of Fire, a geologic battleground where the Philippine sea plate is diving beneath the Eurasian plate. This subduction process melts rock deep within the Earth's mantle, creating chambers of magma that are less dense than the surrounding rock, and therefore must rise. Mayon is the surface expression of this immense subterranean engine. It is famous for its perfect symmetry, a feature that geologists explain is a result of the consistent central nature of its eruptions. Unlike other volcanoes that might blow out their sides, Mayon tends to erupt vertically, continuously adding layers to its steep flanks, maintaining the shape that makes it a global icon, often compared to Japan's Mount Fuji. But this perfection is also what makes it so dangerous. Its steep slopes, angled at 35 to 40 degrees, give gravitational acceleration to anything that comes loose from the summit. This is the part the headlines do not capture. A pyroclastic density current is not smoke. It is not a cloud of fine dust. It should be understood as a fluidized, high-density avalanche. It is a turbulent mixture of pulverized rock, superheated volcanic gases, and entrapped air, all moving as a single, ground-hugging mass. When a lava dome at the summit becomes unstable and collapses, or when an explosive eruption column can no longer support its own weight and falls back to Earth, a PDC is generated. Temperatures inside can exceed 1,000 degrees Celsius. Its speed is breathtaking, often surpassing 100 kilometers per hour, faster than a car on a highway. Dr. Ma. Antonia Bornis, a leading expert on Mayon at PHIVOLCS, has described them as the single greatest hazard the volcano produces. The kinetic energy is so immense it can flatten forests and buildings. The heat is so intense it flash vaporizes water and instantly incinerates any organic matter in its path. There is no surviving exposure. It is absolute destruction. This is the force that is now, once again, descending the gullies of Mayon Volcano. The local Bicolano term, Uson, carries with it this inherited cultural memory of the phenomenon's destructive power, a word passed down through generations who have witnessed it firsthand. Now, here is the part nobody is putting on the news. The current activity is not an isolated incident. It is another chapter in a relentless, centuries-long cycle of destruction and rebirth. Mayon is the most active volcano in the Philippines, having erupted over 50 times since the first documented event in 1660. A major eruption occurs, on average, once every decade. The documented history is a litany of destruction. There were significant events in 1928, in 1968, and 1978. Then the frequency appeared to increase. An eruption in 1984 forced the evacuation of 73,000 people. The deadly 1993 event was followed by an extended eruptive period from 2000 to 2001, another crisis in 2006, then again in 2009, another in 2014. The most recent major event, in 2018, saw the alert level raised to 4 and displaced more than 81,000 people at its peak. The interval between major crises has collapsed from multiple decades to a handful of years. The volcano is a chronic threat, and the historical data suggests that each eruption is simply a prelude to the next. But to truly understand the scale of devastation Mayon is capable of, you must look back to February 1st, 1814. This was not just an eruption. It was a civilization-ending catastrophe, what volcanologists classify as a Plinian eruption. On that day, the town of Cagsawa was a thriving community at the foot of the volcano. It had a stone church, a convent, and a bustling population. Eyewitness accounts from that morning describe a violent explosion from the summit that shot a column of ash and tephra kilometers into the sky. But the deadliest part was the pyroclastic flows that followed. Immense, fast-moving Usons swept down all sides of the volcano simultaneously. They were far larger and more voluminous than anything seen in modern times. The flows completely buried the towns of Cagsawa and Budiao. They heavily damaged Kamalig, Guinobatan, and Malilipat. Sources from the time report that the incandescent material, mixed with mud and water, formed volcanic tsunamis of debris that buried the landscape under meters of rock. Over 2,200 people were killed in the 1814 eruption, the deadliest in Mayon's recorded history. Hundreds of residents of Cagsawa had taken refuge inside their sturdy stone church, believing its thick walls would protect them. The pyroclastic flow overran the structure completely, collapsing the roof and burying all but the top of the bell tower. Today, that single stone belfry is all that remains. It stands in a field of volcanic rock, a solitary iconic monument to the 1814 disaster. It is arguably the most powerful symbol of volcanic risk in the entire Philippines. A photograph of the Cagsawa ruins, with the perfect cone of Mayon looming in the background, serves as a permanent chilling reminder. Dr. Renato Solidum Jr., the former director of PHIVOLCS, has often cited the 1814 eruption as the ultimate benchmark for Mayon's destructive potential. It proves that the entire area around the volcano, far beyond the modern 8-kilometer danger zone, has been and can be inundated. The event was so powerful it caused a volcanic winter, with heavy ashfall leading to crop failures and darkness across the region for days. The landscape itself was permanently remade. The Cagsawa bell tower does not stand in a valley. It stands on what is now high ground, a plain built entirely from the debris of that single cataclysmic day. This history informs every decision made today. The modern response system is a complex and massive undertaking, designed to prevent a repeat of 1814 or even 1993. The primary responsibility falls to the Philippine Institute of Volcanology and Seismology, or PHIVOLCS. Under its current director, Dr. Teresito C. Bacolcol, the agency operates a sophisticated network of instruments on and around Mayon. This includes seismometers to detect underground magma movement, tilt meters and GPS to measure ground deformation as the volcano inflates, and spectrometers to analyze the gases being emitted from the crater. When these instruments detect a significant change, PHIVOLCS raises the alert level on its 5-point scale. Alert level 3 signifies a high level of unrest and the presence of magma at the crater. Alert level 4 warns that a hazardous explosive eruption is imminent or in progress. Level 5 means a life-threatening large-scale eruption is underway. The declaration of these alert levels triggers a massive, cascading response from other government agencies. The National Disaster Risk Reduction and Management Council, or NDRRMC, coordinates the national effort. The provincial government of Albay, through its highly regarded Albay Public Safety and Emergency Management Office, APSIMO, implements the on-the-ground evacuations. The Department of Social Welfare and Development, or DSWD, manages the sprawling evacuation centers that must house tens of thousands of people for weeks or even months. The economic impact is staggering. Agriculture, the lifeblood of the province, comes to a complete standstill inside the danger zones. The city of Legazpi, a major economic hub with a population of over 200,000, sits just 15 kilometers from the summit and often finds its airport closed due to ashfall, a decision enforced by the Civil Aviation Authority of the Philippines, CAAP. The 2018 eruption alone cost the province millions in agricultural damage and lost productivity. This creates the central paradox of life under Mayon. In its quiet phases, the volcano is the region's greatest asset. Its iconic shape drives a thriving tourism industry. Its rich volcanic soil produces valuable crops. But during its active phases, it becomes an existential threat that can bankrupt the province and displace a significant portion of its 1.3 million residents. The evacuation of over 81,000 people in 2018 was a logistical triumph, but it stretched resources to their limit. Families were forced to live in temporary shelters, often schools and gymnasiums, creating a secondary crisis in health, sanitation, and education. And then there is the existential question buried within the volcanological data. Mayon's perfect cone is a deception. It suggests stability and permanence. The reality, as noted by volcanologists like the late Dr. Eduardo P. Laguerta, who spent his life studying the volcano, is that the steep slopes are inherently unstable. The constant emission of gases and the intrusion of new magma weakens the rock, making summit collapses more likely. The beautiful symmetry is actually a sign of its relentless, dangerous activity. The volcano appears to be a static object, a mountain, but it is not. It is a process. The nighttime crater glow, which locals call banag, is a visible sign of the heat engine working just below the surface. A quiet summit does not mean a safe volcano. It means a sealed vessel where pressure is building. The 1993 event proved that a deadly eruption could occur with almost no immediate warning. The current pyroclastic flows, though small, are confirmation that the system is open and active. The magma is at the surface, and the potential for a larger, more explosive event remains constant. The 6 to 8 kilometer permanent danger zone is not an arbitrary line. It is a data-driven calculation of the reach of these flows based on decades of observation. But as the 1814 eruption proved, a truly massive event could render those boundaries meaningless. For now, PHIVOLCS continues its 24/7 watch. Communities like Daraga and Tabaco City, which lie on the volcano's immediate slopes, are in a state of heightened alert. The descending pyroclastic flows carve deeper into the gullies, depositing new layers of hot debris. This material will later be remobilized by monsoon rains, creating secondary hazards in the form of lahars, fast-moving volcanic mudflows that can inundate river valleys and bury towns miles away from the summit. The danger from a single eruption does not end when the shaking stops and the ash settles. It lingers in the landscape for years. The current crisis is a stark reminder that the 500,000 people who live in the shadow of Mayon have made a bargain with one of the most powerful and unpredictable forces on Earth. The question is never if it will erupt,